There is a place on Earth where it has not rained in 2 million years. Not a dry spell. Not a drought. 2 million years. To give you a sense of what that number actually means, the last time significant precipitation fell on this ground, our species did not exist yet. Homo sapiens wouldn't appear for another 1.5 million years. The mammoths were still alive. The world was unrecognizably different, and yet this patch of ground has sat here, bone dry, through all of it, completely unchanged. The place is called the McMurdo Dry Valleys. And the first contradiction, the one that sets up every other absurdity that follows, is this: it sits in the middle of Antarctica. Antarctica, the continent that holds 70% of all the fresh water on Earth, locked inside glaciers and ice sheets that, in places, are nearly 3 miles thick. Antarctica, where it snows constantly, where visibility drops to 0 in seconds, where everything is white. And buried inside that continent, roughly 60 miles from the nearest research station, is a stretch of bare, brown, gravel-covered land the size of a small country, about 4,800 square kilometers, where the ground is naked rock, the humidity hovers near 0, and the sky has stayed dry for longer than humanity has existed. This is not a small quirk. This is one of the most extreme environments on the surface of the planet. And the more you look at it, the more it refuses to make sense. So let's start from the beginning. How does something like this even happen? The Transantarctic Mountains run like a spine across the continent, with peaks rising to around 9,800 feet. As moist air pushes in from the coast, it is forced up and over those peaks. As it rises, it cools and loses its moisture. All the precipitation falls on the windward side. By the time the air drops into the valleys on the other side, it carries almost nothing. That's the first layer of the mechanism, and it would be enough on its own to create a dry zone. But what makes the McMurdo Dry Valleys extraordinary is the second layer. Katabatic winds. These are not ordinary winds. Katabatic winds form when dense, cold air from the high polar plateau spills downward through the mountain passes and accelerates under gravity. In the McMurdo Dry Valleys, these winds can reach speeds of up to 320 kilometers per hour, nearly 200 miles an hour. They are so fast, so dry, and so relentless that they do something physically remarkable. They evaporate snow and ice directly into vapor without it ever becoming liquid first. The scientific term for this is sublimation. The practical result is that any snow that manages to reach the valley floor simply disappears. The wind erases it before it can accumulate. The mountains block moisture from getting in. The katabatic winds eliminate whatever does get in. The average annual precipitation, what little falls at all, comes in as light snow, the equivalent of maybe 6 centimeters of water a year in some areas, and effectively zero liquid rain, in some parts of the valleys, for as long as scientists can measure back. Some specific areas within the valleys, researchers believe, have seen no significant precipitation at all for approximately 2 million years. 2 million years of unbroken dryness. In a place surrounded by ice. When Robert Falcon Scott and his party stumbled into what is now called Taylor Valley in December of 1903, they were among the first human beings to ever lay eyes on this landscape. Scott wrote in his journal about it as, "the Valley of the Dead." He and his men had walked for days across the ice sheet, expecting more ice on the other side, and instead found themselves standing in a barren, brown, wind-scoured wasteland. He wrote that they had seen no living thing, not a moss, not a lichen. The great glacier that had once filled the valley, he noted, had withered away. His expedition companion, geologist Edward Wilson, reported finding the remains of old seals lying on top of distant glaciers, and assumed they had crawled there to die in peace. Nobody, at that moment, could explain any of it. Scott left, and the world largely forgot the place existed for nearly half a century. It wasn't until the 1950s and 1960s, when the U.S. military's Operation Deep Freeze began mapping Antarctica in detail, that scientists started returning to the valleys and properly cataloging what Scott had seen. And what they found, piece by piece, was so strange that it started attracting researchers from geology, astrobiology, glaciology, microbiology, and space science simultaneously, each discipline arriving and finding something that made no sense by the rules they had learned. Let's take the lakes first. You would not expect lakes in the driest place on Earth. But the McMurdo Dry Valleys contain more than 20 of them, scattered across the valley floors, permanently covered by 3 to 5 meters of clear, hard ice. Underneath that ice, liquid water sits in complete stillness year-round. The ice acts as an insulating lid. Without it, the water would evaporate into the katabatic winds in a matter of years. With it, the water is trapped and protected. In some of these lakes, the water column stratifies so dramatically, denser, salter, warmer water sinking to the bottom, that the deepest layers, in the case of Lake Vanda, can reach 25 degrees Celsius, which is 77 degrees Fahrenheit, at the very bottom, while the surface air temperature stays well below freezing. A lake that is warmer at the bottom in winter than most swimming pools. In Antarctica. And then there is Don Juan Pond. In October 1961, two U.S. Navy helicopter pilots, Don Rowe and John Hickey, were on a reconnaissance flight over the Wright Valley when they spotted something that made no sense. A small pond, maybe 300 meters long, sitting in the open air with no ice on it whatsoever. The air temperature at the time was around minus 24 degrees Celsius. That is well below the freezing point of water. But the water was not frozen. They landed, and confirmed what they were seeing. The pond was named after them, Don for Don Rowe, Juan for John Hickey. Scientists have been arguing about it ever since. The reason it doesn't freeze is its salinity. Don Juan Pond contains calcium chloride in concentrations so extreme, salinity above 40%, that it is roughly 12 times salter than the ocean, significantly salter than the Dead Sea, and so dense that the water appears thick and syrupy. Calcium chloride is extraordinarily hygroscopic. It pulls moisture directly out of the air. Research from Brown University geologists, published in the journal Scientific Reports, found that the pond is actually fed not by groundwater, as scientists had assumed for decades, but by atmospheric moisture being extracted from the air by salt-saturated soil, which then seeps into the pond. The water can remain liquid even when temperatures plunge to minus 58 degrees Fahrenheit, cold enough to freeze almost every other natural liquid on Earth. For decades, researchers believed it was the saltiest natural body of water in existence. Whether life can survive in it remains actively debated. But hold on, because we haven't reached the river yet. Antarctica's longest river runs through the McMurdo Dry Valleys. It is called the Onyx River. It stretches 32 kilometers through Wright Valley, draining into Lake Vanda. New Zealand scientists began monitoring it systematically in 1969. And here is the detail that makes it perfect: the Onyx River flows away from the sea, not toward it. A river with no outlet, flowing inland, into a closed basin that has no connection to the ocean. Its water will never reach the coast. The river exists only during the austral summer, roughly November through January, when air temperatures creep above freezing for a few weeks and glacial melt produces enough flow to trickle down the valley. In some years, it flows strongly. In some years, it barely reaches the lake at all. But when it does flow, through the driest desert on Earth, surrounded by rock and wind and zero precipitation, it is one of the more quietly surreal things that exists on this planet. Now, here is the part that completely changes the character of this place. Scott called it the Valley of the Dead. His assessment was reasonable. For most of the 20th century, scientists assumed that the McMurdo Dry Valleys were essentially biologically sterile, that conditions were simply too extreme for life to take hold. The temperatures range from minus 14 to minus 30 degrees Celsius on average. There is no liquid water on the surface most of the year. There are no plants. There are no animals. There is almost no food source of any kind. But then researchers looked more carefully. Not at the ground. At the rocks. Inside the sandstone boulders and outcrops that litter the valley floors, scientists found life. Not on the surface. The surface is too cold, too dry, too bombarded with ultraviolet radiation. But just a few millimeters inside the rock, in the tiny pore spaces between grains of sandstone, microorganisms had found a habitat. The rock absorbs just enough sunlight to create a marginally warmer, marginally more humid microclimate inside itself. Cyanobacteria, algae, and fungi had essentially evolved to live inside rock, using the stone itself as a greenhouse. These organisms are called cryptoendoliths, hidden life inside stone. They are among the most stress-resistant organisms known to science. When researchers have examined these communities, they have found that the organisms can survive years of desiccation, entering a dormant state and then reactivating when conditions allow. They are, by almost any measure, living at the absolute edge of what biology can do. That discovery changed how scientists think about Mars. NASA had been using the McMurdo Dry Valleys as an analog for Mars since the 1970s, when instruments being prepared for the Viking landers were tested here because the conditions most closely matched what was expected on the Martian surface. The Viking landers, when they arrived, found no definitive sign of life. But subsequent researchers pointed out that Vikings' instruments, when tested in the McMurdo Dry Valleys, also failed to detect the life that was actually there, the cryptoendolithic communities inside the rocks. The technology was not looking in the right places. The McMurdo Dry Valleys are now considered by NASA to be the best single terrestrial analog for Mars on Earth, and research conducted here directly shapes how future Mars missions are designed, what instruments they carry, and where they point their sensors. Which brings us to the glacier that bleeds. In 1911, geologist Thomas Griffith Taylor, the man whose name was later given to Taylor Valley, looked at the snout of a glacier and saw something he could not explain. A dark red stain was running down the ice face, pooling at the bottom, seeping across the frozen lake below. It looked, unmistakably, like blood. He wrote it down and moved on. The feature sat in scientific literature mostly unremarked for nearly a century. Blood falls is now one of the most studied features in the entire region. What Taylor was seeing was brine, ancient, iron-saturated saltwater, pushing up from beneath the glacier through fissures in the ice. This brine is thought to come from a subglacial lake that may have been sealed beneath Taylor Glacier for more than 1 million years, cut off from the atmosphere, from sunlight, from the outside world entirely. Inside that lake, in perpetual darkness at sub-zero temperatures, microorganisms are alive. Not fossilized. Not dormant. Alive, running an ecosystem on chemical energy alone, with no photosynthesis, no sunlight, no oxygen, just iron and sulfur and ancient brine. The brine itself is clear when it is underground. The moment it meets air, the iron oxidizes instantly, the same process that turns iron red when it rusts, and the waterfall runs crimson. Researchers from the University of Alaska Fairbanks used radar to trace the path of the brine from the subglacial lake through a 300-foot network of channels inside the glacier before it emerges at the surface. Their study, published in the Journal of Glaciology, confirmed that liquid water can persist inside glaciers at temperatures as low as -17 degrees Celsius, something scientists had previously thought was essentially impossible. And somewhere in those same valleys, scattered miles from the nearest coast, occasionally found at elevations above 1,500 meters, baked and mummified by the katabatic winds, there are seals. Crab-eater seals, Weddell seals, leopard seals. Found desiccated and preserved in the dry air, sometimes hundreds of years old. Carbon dating has placed some of the mummies at 2,600 years old. One expedition catalogued more than 300 mummified crab-eater seals in the valleys. Scientists' best current theory is that young seals, disoriented during Antarctic winter blizzards when visibility collapses completely, crawl inland in the dark instead of back toward the sea, traveling mile after mile across gravel and rock before finally stopping. The cold, dry air mummifies them perfectly. No scavengers. No bacteria. No decay. They simply remain, frozen in time, in the valley of the dead that turned out not to be dead at all, just alive in ways that no one thought to look for. There is something almost philosophically uncomfortable about the McMurdo Dry Valleys. Every intuition fails here. Ice continent, no ice. Driest place on Earth, rivers and lakes. No life possible, life inside every rock. A glacier that bleeds. A pond that will not freeze in temperatures cold enough to freeze almost everything else. A river that flows away from the sea and vanishes into a closed basin. NASA keeps coming back. Scientists from 30 countries have set up field camps in the valleys. It is, by the assessment of multiple space agencies, the closest thing to another planet we have on this one, specifically Mars, cold and windswept and chemically strange, with liquid water hiding in improbable places and microbial life persisting at the absolute boundary of what is biologically possible. What the McMurdo Dry Valleys ultimately demonstrate is something the rest of Antarctica actually obscures, that beneath the ice, beneath the cold, beneath everything that appears totally hostile to existence, the definition of alive turns out to be far stranger and far more stubborn than we assume. The valley Scott called dead has been telling us something about life, on this planet and possibly others, for as long as the ice has been melting into it. It just took us a very long time to look inside the rocks.